Hello, welcome to the next episode of the Multiplatform Architect. And today we are going to be implementing the window size, the window size class. So what the window size class does is like it acts as an adaptive tailor. For example, in this scenario, we are going to see how we can obtain different sizes on different devices. So for example, when you're on a small phone, like these normal phones that we use, we shall find that we always have different width compared to tablets and also compared to desktop or even web when the window is expanded. So that's why we shall have different categories. For example, compact, you have medium, for example, for tablet, expanded for laptops or tablets, and then extra large for ultra wide desktop screens. And now in this case, let's start implementing it. So we shall come under the core with the platform and we shall create our new class and we shall call it the window size class. File. And then what we shall do in this file, we shall try to create an enum class. So I'll explain as we move on. So enum class size. We shall define different categories. We have compact, we have medium, medium, spelling okay. Then we have the expanded, then we have large, and also have extra large. And is capital L, so that's what we So what this enum does, it's like it defines the standard breakpoints uh, used across the project to achieve a truly write once, run everywhere experience with Compose Multiplatform. And that's why we find we have compact, and this is typical for fonts, as I explained. For different widths, we shall be seeing the width that we always deal with. Then for medium, this is for example for tablets or maybe foldable phones. And then we have also for large, expanded. So now this for expanded can be for laptops, among others. And this can be able to display, like for example, two pens that can be, imagine you have like a chat screen, or you have also the detail, and you're all showing them on the same page. And you also have this large. Now this one can also uh, accept, for example, 3 pens, and then the extra large is for ultra wide desktops. So you can find desktops have large screens. That's where the extra large comes in. So after that, after defining our enum class with different sizes, we shall try to come and implement an expect function. Expect there possible, so, and expect function that we remember window size. This function will extend window size. So okay, what this function does is like this composable provides the current, for example, the current window size class based on the screen width. So this is the cornerstone of building adaptive layout. So meanwhile, what it does, it bases on this window size to provide uh, the exact adaptive layout that we need. Because, for example, when you reach a desktop, you will find that the desktop will have maybe large or will have the extra large. So, we shall be using this to access these different screens. And then we shall continue. Try to call it expect fun remember and this function will extend this provides row width of the window in DPs. So use this for fine-grained animations, or maybe can be custom responsive calculations that go beyond standard window size. And then finally, we shall be finding that we have to return the current width of the window or screen when we are dealing with this expected function. And then after defining this, we shall also find that we will have to be having a helper function that then will help us to convert the pixel-based values into compose-friendly DPs. And that we can try to also declare another composable. This we can call it an expect fun int dp two pixels. That's a function that we just this function to extend the DPs. So now we have our enum class, we have the window size, the window width, and also the conversion, the function that will help us to convert the pixel-based values, are usually from platform APIs. It can be on Android, it can be whatever. So then to compose friendly DP using compose multi-platform. So after implementing this class of ours, what we did is that we shall have to create actuals in different platforms. So just come here, then for JVM, just click here, then you create it here. Okay, then we shall also come create it for Android main. And we shall also come also implement it for JS. We shall also have to implement the actuals for the remember window width, and we also do it for JVM. So then, after creating all the possibilities of all these functions that we have here, we shall have to navigate to each of these new classes that we've created in different platforms, implement the actual logic that will be enabling us to be able to have that adaptive feature in our Compose multi-platform application. We are going to start with implementing the actual implementations of these functions in our Android main. So we shall navigate to the Android main, then we shall go to Kotlin, and then we go to our core in the platform, and then we find this file. So now, in this case, for example, when we are to begin with the remember WindowSize, we shall find that in this, we can decide to define, for example, val context, the local context. And since we are in Android, we can be able to use context parameters or context current. So what this does is like for Android, it always requires an activity to calculate current window. So in most cases now, after defining the context, we shall also come here and then we define val activity. Is equal to context. Now in this case, we will have to again maybe define an extension function that will help us to this function. So we shall declare this one here, shall put it here, then we shall also come here, and we are going to try to create a helper function, and this is file context find activity, then we shall extend it the activity, the activity, then nullity. And these brackets, but then we need also. So now, what this import, this extension, this helper function will be doing is like it will help us to traverse the context tree, to find the nearest activity. So in most cases, this is essential for calculating the window size class. and we shall be seen as we continue. So now what we'll do, shall declare a var which is context, and then we shall assign it. We'll assign it to this. And enter here, then we shall while context is context wrapper, not context wrapper. Okay, and if shall declare if function context context is the context that if then shall return context, and then this is good in our if loop, then we shall continue and say okay, the context is equal to the context this context. All right, but then as we see here, we say that this means a return expression, and if we are done with all this, we shall have to return a null. Return here I am okay. So after working on our helper function, we shall come back. Now we can see this one is settled. Now we shall also come and also declare another variable which we shall call the window width, and this is local configuration relation dot current statistics in screen dp. And what this does is like in Android, this calculates with the time, so we use its own values. It's first this here. There's also another variable size class. Size class we go into you can say to the if function if our activity is not equal to null. What will we do? If our activity is not equal to null, let's try to see null. We shall try to calculate. Calculate the window. I think you can be able to see it to just come up the window size class, and then we shall pass an argument which is activity, and then we shall also extend the width class size. Okay, then else if this is not true, what shall we do? This is shall put a window width size class and compact. And now we see some here. Still experiment, so we have to extend that one there. So what this variable does is we shall first see if the activity is not null, then we shall have to calculate the window size class. Then we see which parameter can we assign. Is it compact? Is it a medium? Is it expanded or something like that? But if we find that it is null, then we shall have to resort to compact on Android. So for the other, it can be less than 600 dps, as we shall be seeing. But then we are able to see that we still have to put a return function. So in our return function, we shall have to implement the actual sizes. So return shall have to declare a when expression, and in the expression we shall pass our window size class that we just declared above, and then this class sorry. Shall then shall the window width size class. It's compact. Okay, then lambda window size, then dot compact. Now this is where we're using our inner, providing all these values, the compact, the medium, the others. Then when if we have our window with size class dot medium lambda window size dot medium, also assign large class expanded, expanded, expanded lambda shall put the window size expanded. Then, but actually now this is a little bit not good because on our phones, from this class it only provides 3 values. So this means that we shall get a way of being to of handling also the other remaining values of the large and the extra large. So what we shall do, instead of us assigning this RAM the window size that expanded, we shall expand it more, and now also get another one function inside. So after putting this one function, then we say the window width, that we declared that gets the screen that calculates the width internally. So we can get the screen's values. We shall say that the window width in this case, if it is less than 1200 values, if this is its width, then we use a lambda to assign this to the window size dot expand. Okay, and then if we have our window width, switching here, we have our window width, which is less than 1600 degrees. So what you have to do, you assign this to window size large. Then if none of these is there, we shall have to forget else this that then assign this value to the window size dot extra large. Alright, so we also have this when expression. So if all this fails, we shall find that our else we shall go back to the window size dot expanded. And now we are done with our member function. So this will help us, it will allow us to see even further into the distance for the desktop, ultra wide, than standard lens is allowed to. So meanwhile, we shall find that this class would be helping us calculating different sizes, which compact, with medium, expanded, and then if it is around this, what do we deal with? How do we assign it expanded or large? So after that, we also have to implement this one. Yeah, so this function, literally the whole of this function here, this row will be able to provide the current screen with the DPs using Android specific configuration. So how can we implement this? So what we are going to do, we are going to just return an expression. So we return the local configuration. So we return the local configuration current dot screen, and now here we are done with this one here. And then when you come to also need to implement this actual, and this actual will be necessary. For example, on Android, this will be able to use the local density to handle different screen densities. For example, it can be MDPI, HDPI, whatever. So now we shall have to extend this to finish returning. Try to return with and now this will need the receiver, so we pass in the local density, local current, then also have assign a body. This body we shall pass this dp pixels. Now this one first we and there, so they are saying this much. So we shall have x3.2 dp dp, and yeah, this is done. So now we've finished implementing our WindowSize actuals within the Android. So now this means we shall be able to handle every adaptability when it comes to Android. Maybe it can be tablets, maybe it can be everything. So this class will be able to handle everything dealing with adaptive UIs in Android. So when you expand to a tablet, or when you contract to a compact medium phone, or when you have a large iPad, or maybe any large device that is an Android operating system, how does the window behave? Or how does it expand? How does it look like? All those things will be handled by this WindowSize class. So after implementing the Android, we shall have to also implement for other targets. So we can try also for JVM, so we shall also come here. And now we shall notice that for different targets, we have different ways of implementing this logic. And then when it comes to desktop, we shall find that we shall have to declare new variable local window local window. I'm going to explain what this actually does. So we shall find that a composition local is used to provide the window width from the root. That is like the main Kt file within our desktop target that is here. And then what it does, it passes it to any descendant within the UI tree. So in most cases, whenever, for example, whenever you're dealing with adaptive window within a desktop, maybe you're expanding, so we don't have to actually pass within each of the sizes. For example, I'm within the extra large, and then I want to go to the large, and I want to get the expanded. I don't have to pass through the large and then like all those things. So what this does, it gets the width, and then actually it goes to that specific width that the user has navigated to without again having to navigate each of them. Maybe if you want to navigate to that specific size of the screen. So that is what the local composition does. So it's used to provide the window width from the root to any descendant within the UI tree that is within the main tree. So now we are going to implement actual function over here, and we shall also depend on the variable that we just created. So this will only return the local window width that we just current. Okay, so now this expression, what we'll do, to just read the window width from the local window width provider, and then after that we also have implement this guy over here. We shall have to also implement this function over here, and this one shall implement it the same way we did for Android. And then after that we shall also have to implement our last option, which will be the rememberWindowSize, and we shall find that this rememberWindowSize, as I explained with Android, it maps the width provided. Now this one will map the width provided by this local window width to a window size. So now let's first implement it and see how it will look like. So we shall select var and pass in a new variable called the local window width dot current. So try to get it. And afterwards, we need a return expression, and as we did with Android, so we shall have to pass now when function. So when, all right. So when the window, now we shall provide actual, we shall provide width of, shall provide actual width of the window sizing. So we shall have, if the window width is less, the window width is less than 600.dp. What are we going to have? We shall have window size, window size from the platform. Okay, dot. Okay, compact. All right. Then if our window width is less than 840, 840 means we shall have size. Shall have our window size 2. So right now, after finishing to implement the whole of this class, it will enable us to be able to transit from different window sizes with ease. And now we can be able to see that we used values which we created by our own self for the window width. And then we shall see that in Android, we only use them here because for Android it already contains an API for Material 3 that already provides these different parameters that could be different sizes. So that means that we only had to add these ones to make it uniform to our values, for example, for desktop, for web, and yeah, even to apply to iOS, that's the same thing. And this will bring us to our topic of Compose multi-platform. Now, after implementing the desktop and the Android actual functions for the window size, now we shall have to navigate to the web. And now for the web, we have JS and the WebAssembly, but now we'll speak in JS. And a few notes to note about the JavaScript target. It's like this one works on legacy browsers, among others. But you have to also notice that for WebAssembly is quite faster than this one for the JS. Yeah, and for JetBrains, it's trying to push more of the WebAssembly. And for now, what we have to know is that in web development, it is unique in the way we implement the responsiveness and the adaptability. With the fact that the device changes while the app is running. Now, what does that mean for us? This means that we don't just detect the size at launch, rather than we can stay alert using listeners, for example, as we are going to be seeing in our implementations. So right now, we are going to begin by implementing some of the things, and now I think you're already familiar with this one here because everything does not change. Then we shall come here. So first and foremost, what we have to do, we shall have to create a helper function. Then we shall be seeing its use as we continue to implement our actual implementations of the functions that we declared with the common main. So in this case, we are going to declare a private, let's say val screen is equal to window. Shall try to this. Okay, is equal to window, and shall try to import this from Kotlin X browser. Okay, import trying to get its inner width. I need to import this one. Okay, hit enter. Then I will have to return when function when. Okay. Now what will I pass in the when? Now in the when, the screen width is less. The screen width is less than 6. So literally, this is the same as how we did it in the desktop. So meanwhile, by me repeating all this code, I'll just come here and copy all these variables here. All of this will copy. Now come back to the JS main, and I will just paste it here. So instead of the window, let's put the screen. And let's align this. Okay. Now we are done with this function. Now, what does the whole of this function do? Now, this means that this function maps the current pixel width of the browser. So this one maps the current pixel width of the browser to our design system. Our design system's window size. So this means that if the browser is in this, then we shall get the compact. If we are in 840.dp, if the screen size has this width, then we shall put the medium. Like that. So it is mapping the current pixels. And so if the current pixel is this, then we shall have to map our design system to this one here. So yeah, that's what this one will be helping us to do. When we come to browsers now, there is this concept that we have in browsers, that in browsers we often use flows, like, but then we need to create helper functions that will be able to help us to turn the browser events into Kotlin streams in this case. So in this case, we shall have to create a private fun event. Okay, then we shall have to get it from the this input here, the DOM events. So we shall import this one here, then we shall a function event flow, and inside the flow we shall pass in the event name, and this will be a string. Okay, so after that, then the whole of this one will be equal to. So okay, now what we are going to do in this case, we are going to create a concurrent channel. So what our channel will be doing, it will be taking the latest event, however events that occur, it will be always taking the latest. So the channel, and okay, curtains, and then say channel as an event, and the event from the DOM events, and I shall also channel curtains, then the plated, also inside the also block, pass in the channel. And then we also have initialize listener, and listener to which is unit is equal to passing the body, which will be the channel, and dot try saying it. Now, what this listener will be doing is that it acts as a callback. So this is where we shall be bridging the Kotlin and then the JS. So this will be acting as the JS Kotlin bridge. Okay, so after declaring our listener, we shall come and shall say add event listener. So the add event listener shall pass the event name, or event name, and also listener. Okay, so what this also will be doing is that it tells the browser to start sending events. So this is like subscribing maybe to that event. Now in this case, it's like we are going to implement another feature, which is the channel block on close. On close, then we shall remove event snap. This different event name and snap as well. So this one for it is like a cleanup. It's like a cleanup. So it's critical in most cases when you're dealing with listeners. So what it does, it's like we always have to tell the browser to stop. In most cases, when the component is destroyed, and yeah, that's how it works. So when the component is destroyed, we have to tell the browser that hey, this component has been destroyed. Then let's do what? Let's remove the listener. And after all this that we've been doing inside this body here, we shall have to receive, uh, receive, have my experience, okay. We shall have to receive, okay, receive as flow. And this exposes the channel as an observable flow. So now we've finished our function here. So now what we are going to do next is that we have to create a high level analysis for resizing our events. So now what we shall do is, now this is the one we shall be using also one of these expect actual functions that we have here. So now what we shall do, we shall create a private function, event target dot size flow to event flow the area, and then we shall pass in name and event name, and now in sketch let's call it size. Okay, that's it. So we shall have to implement one of these one by one. So I see there is a typo. Try to correct it. Okay, so we shall go on and then we implement this function here. So instead of this, we are going to declare a variable window width by state. This state shall initialize and our initial value. Oh, it seems I didn't. Okay, initial value. Initial value is the window So now what this does is that it turns the external data source into a compose state. Here we just set the starting width immediately, so there is no figure dealing with our, or let me see, that says specify the arguments. So now in this case, after implementing our WindowSize class for the JavaScript, we shall have to also implement for the WebAssembly. But then we shall find that for the WebAssembly and the JavaScript, they all have the same logic when it comes to implementing this WindowSize class. And the reason to why I didn't include it in the web main is that in the web main, this could be the best part whereby I just implement the feature that I want to share on the JVM, and also not the JVM, the JS and the WebAssembly, that they can have the same implementation at the same time. Though for the web main right now, if to include this logic, it will just give me error because some of these imports are not there as of now. I think JetBrains will have to work on that. What we shall do in order to save our time, just go copy this, come to the WebAssembly target, then just paste. And as you can see, it will be working very fine, no errors, and everything. That means that we are good to go. So right now marks the end of the implementation of our WindowSize class from expect to actual implementation. So now this means that when you create a class and then your desktop, maybe extra large or maybe large, even your Android phone, maybe tablet, the screen will be able to adjust itself depending on the pixels rendered for the width or anything like that. Now that we've implemented all the WindowSize classes, now what we are going to do is we are going to test and then see if our logic is really working as expected. So what we are going to do, we are just going to come to the app file, and then we shall find this this UI that always comes with the template. So what we are going to do, we are going to first remove this one here, and we are going to initialize a variable size, which is the size to remember the size. So I'm going to create it. import it. Then after shall define var is large screen. Okay, large screen. For now, we're going to consider it if. Okay, now window size. The window size is greater equal to the window size. Size. Let me comment dot. For now, we can try to use expand it. Okay, so when the window size is greater, not less, is greater, size is greater or equal to expand it. In what we do, just if, okay, if it's large, if large screen is true, what we will do, okay, what we shall do, we shall put the box because we want to test it out. This box is modifier, that is modifier 2. Modifier max size. Okay, we also need a background. So what we have to do is background. We can try to pick the colors from material theme. So we shall just get the material theme, then dot color scheme dot primary. The primary, this is for the primary, then set our content. So content alignment is equal to alignment is equal to alignment center. Okay, so inside the box we need the body. So let's export the text for now. It's okay. Now in this one, style and material dot typography dot contract is the body large. And also let's maybe give it a color. Color material theme. Material theme dot color scheme dot primary. Alright, so after getting this, instead of repeating it, just copy it and then import it into else block. So if we find that it's not a large screen or to print, so we shall just change this color to maybe okay. This will make it secondary. Alright, so these colors are predefined in our scheme. And after this means that if we find that it's not a large screen, and then the small screen shall display this. If it's a small screen, the large screen shall display this is a large screen. So now what are we going to do? For now, I just want to run the main app, so I'm just going to come here. For now, if I run it, it won't be able to do it because I have to provide the state. So what I will have to do is start again. I like state is equal to remember window size, window state. Alright, so window state. Now come into this window block, pass the state, window state. Then after that, I'll have to this body, the composition logo provider, and I will then use the logo window that we declared. Okay, now this is the local window that we then provides window state dot size. Okay, right. Then after its body, and then let's give this up and pass it to this local provider. So now when we run our app, it should be able we should be able to display that. So let's come here. We shall just come and click run. Alright, so we shall just wait and we run, and we see to be able to resize on different screen sizes. But for now, we're just using the is expanded. It is great how you expand it, so it's a large screen. And if it is below, then that is when it is medium and then compact, that then to show that it is a small screen. Actually, now we have to change here. Small screen. Yeah, so after running the application, it will have to show up this window application. So that when we expand, it will show this is a large screen, and then we contract, this will show this is a small screen. So yeah, we have successfully set up the window size class and it's working